In this lesson, I'll show you how to use chemical formulas as conversion factors. This is question 2 in the series. We left off with this question and it reads, determine the mass of oxygen in a 7.2 gram sample of the chemical aluminum sulfate. The chemical formula for aluminum sulfate is shown right here, where we have 2 aluminums, 3 sulfurs, and 12 oxygens. The first thing that we want to do is find the total molar mass of this compound. So let's go ahead and do that. Let's start by writing out aluminum, and its molar mass for one atom is 26.98. 26.98. And I'm going to call it AMU, but it has the units, grams per mole. Then we have sulfur. Sulfur has a molar mass of 32.06. And this can be all found on your periodic table, grams per mole. And finally, we have oxygen. Oxygen has a molar mass of 16.00 AMU, and that's also in grams per mole. Now, the next thing that I want to do is multiply each of these numbers by the amount of atoms within this molecule. So for example, I'll take 26.98 and multiply it by 2 because there are 2 aluminums. I'll take 32.06 and multiply it by 3 because there are 3 sulfur atoms. And multiply 16 by 12 because there are 12 oxygen atoms. 4 times 3 is 12. And once I do that, I'll sum them up and that will give me the total molar mass for one molecule. So let's go ahead and do that on our calculator. We have 26.98 times 2 plus, and I'll put the rest in brackets, that way I don't confuse the calculator, 32.06 times 3 plus 16.00 times 12. Now if you don't have a calculator like this, you can obviously do this in steps and then add them up at the end. I end up with 342.14. 342.14 grams per mole. That is the total molar mass of one molecule. Now they want us to determine the mass of just oxygen. So what I'll do next is take 7.2 grams, which is the total, and multiply it by a version of this number. And of course, by doing that, you end up with the total amount of moles. So I'll take 7.2 grams and multiply it by the flipped version of this number. Notice that right now this number has grams at the top and moles at the bottom. So instead of having the moles at the bottom, I'll leave them at the top. So I'll multiply it by 1 mole. There's 1 mole over here over 342.14 grams. So this unit will cancel out with this unit, leaving me with just moles. Now I'll get the number of moles in 7.2 grams of this chemical. Using my calculator again, and keep in mind that your final answer should have 2 significant figures because we start with 2 significant figures. The significant figures here don't matter because they're considered exact numbers, so we won't consider them as measured numbers. We have 7.2 divided by 342.14. Notice that I multiplied 7.2 by 1, which I'm not showing, and then I divided by 342.14, and that gives me 0.0210. 0.0210, and you can keep a few more numbers if you like. 44 moles. This number right now is very important to us, and I'll put a dot underneath this one just so that I remember that there are 2 significant figures at the very end. What I'll do with this number now is multiply it by the molar mass of oxygen because that is what they're looking for. Here's what I mean by that. I'll take 0.021044 moles and multiply it by 16 times 12 grams per mole. And if you do that, here's what happens. Multiplying this by 16.00 grams times 12 over moles, we'll cancel out the mole unit, and we're left with only grams. So let's use our calculator once more to multiply this. Times 16.00 times 12 gives me 4.04. 4.04 grams of oxygen makes up 7.2 grams of the total. Now, we need to consider significant figures. We need only 2. Remember, everything after the 0 is insignificant, so all you have to do is cancel out that 4, and given that the 4 is less than 5, we won't round that 0 up anywhere. We'll just leave it as 0. So we have 4.0 grams of oxygen. If you want the answer to question number 3, make sure you watch part 3 of this video, and hopefully we'll see you soon.